Next, you will be introduced to compound microscope. The term compound refers to the microscope having more than one lens. Basically, compound microscope generates magnified images through an aligned pair of the objective lens and the ocular lens, which collect light from the object and then focus the light into the eye. In contrast, stereo microscope produces a 3D image of the specimen, while the compound microscope has the ability to magnify small samples that cannot be identified with the naked eye. A compound microscope has multiple lenses, which is the objective lens, and eyepiece lenses to obtain a high magnification of 40, 100, 400, and 1000 magnification power. Next, we need to know the main components in compound microscopy. First, the eyepiece and body tube. The eyepiece is the lens through which the viewers looks to see the specimen. It usually contains a 10 or 15 magnifying power lens. The body tube connects the eyepiece to the objective lenses. Next, the objective lens, which is a very important component in a microscope. They are the closest to the specimen, and a standard compound microscope usually has 3 to 4 objective lenses with different magnification levels. 4, 10, 40, and 100 are the most common magnifying powers used for the objectives. And the color line here, as you can see from the picture, it shows a different magnification power that will be further elaborated. Next, the illuminator that serves as a light source for a microscope, typically located in the base of the microscope. Most light microscopes use a low voltage halogen bulbs with continuous lighting control located within the base. Modern compound microscope uses LED illumination due to its low energy consumption and long life. Next, nose piece that houses the objectives. The objectives are exposed and are mounted on a rotating turret so that the different objective can be selected. The aperture is a hole in the middle of the stage that allows light from the illuminator to reach the specimen. Lastly, the condenser is used to collect and focus the light from the illuminator on the specimen. It is located under the stage, often in conjunction with an iris. The specimen or object to be examined is usually mounted on a transparent glass slide and positioned on the specimen stage between the condenser lens and objective lens. Then, a beam of visible light from the illuminator is focused by a condenser lens onto the specimen. The objective lens picks up the light transmitted by the specimen and creates a magnified image of the specimen inside the body tube. This image is again magnified by the ocular lens, and when higher magnification is required, the nose piece is rotated from low power, generally 40, with the illuminated part of the slide. Occasionally, very high magnification required an all immersion objective lens.